Very important lesson. Synthetic division, remainder theorem, factor theorem, and zeros. Let's go. So we're going to divide this polynomial f of x equals x cubed minus 9x squared plus 20. We're going to divide it by x plus 1. Now, we've learned how to do that with long division. Let's try it out with synthetic division. So synthetic division, here's the deal. Instead of dividing by x plus 1, synthetic division is kind of like a shortcut division. You're going to divide by the potential 0. All right? You're going to evaluate whether or not negative 1 is a 0. Because we know if x plus 1 is a factor, then negative 1 is a 0. All right? And so we're going to divide. And instead of writing the whole polynomial, we're only going to write its coefficients. So we got 1x cubed followed by negative 9x squared. And then here's normally where your linear term goes. You see, you don't have a linear term, so you're actually going to fill that in with a 0. That's true for long division as well. And then a plus 20. So that is my format, and I'm going to draw a dotted line right here, and you'll see in a second why I did that. Okay, so here we go. I'm going to start this division. It's a simple little algorithm. It goes like this. Carry your first guy down. Now multiply. Negative 1 times 1 is negative 1. Now combine. Negative 9 and negative 1 give you a negative 10. Now multiply. Negative 10 times negative 1 gives you positive 10. Now combine. 0 and 10 give you 10. Now multiply. 10 times negative 1 gives you negative 10. And once again, combine. 20 and negative 10 combine to be positive 10. What does this mean? Well, it means that your result, your quotient, is going to be x squared, or 1x squared, minus 10x plus 10, with a remainder of 10 divided by x plus 1. You're good. Okay, just come on in. All right. And if you don't believe that, you can go ahead and try this out with long division. You'll see same result. I did this very slowly, but really this is like half the time at least, at most, I mean. So x squared minus 10x plus 10 with a remainder of 10. Now, what is this stuff about the remainder theorem? So the remainder theorem is actually pretty cool. The remainder theorem could have, and by the way, so very important that we focus on the fact that this has a remainder. All right, remainder theorem says that you could have known the remainder of this quotient by simply evaluating f of c. So it says the remainder of f of x when f of x is divided by x minus c is f of c. In other words, if I would have evaluated this function at f of negative 1, all right, saying negative 1 quantity cubed minus 9 times negative 1 quantity squared plus 20, what would I get? Well, watch. F of negative 1 is going to be negative 1 quantity cubed is negative 1. Negative 1 squared is 1 times negative 9, negative 9, and then plus 20. So negative 1 minus 9 is negative 10. And you know where this is going. Negative 10 plus 20 equals 10. Magic number popped up right over here in two different ways, by evaluation and through synthetic or long division. The number 10 keeps popping up. So the factor theorem, moving right along, says if this evaluation would have been 0, then we could have said that x plus 1 is a factor. But from the get-go, with a remainder of 10 or with an output of 10, you know that x plus 1 is not a factor. Is not a factor of, it's better if I write in cursive, is not a factor of f of x. And to prove this with one final step, if we graph this function, you see that indeed there is no 0 at x equals negative 1. No 0 there. So